everyone. I'm Amanda Egan, the Director of Patient Engagement and Clinical Programs with the RUNX1 Research Program. So I'm here to kick off the webinar today, introducing the RUNX1 Patient Tissue Bank, a new way to contribute to research from home. So many of you probably have heard a bit about this new resource for patients to support advancing our understanding of RUNX1 FPD in a really important and simple way in a lot of ways. So today we have here with us two study team members from the University of Pennsylvania. We originally planned to have Dr. Jimena Jordan-Bruno with us, who is the principal investigator, but unfortunately she had a family emergency earlier this week, so she had to head back to Bolivia. So thankfully, we've been working really, really closely with these two guys, and they'll be handling the bulk of the presentation on her behalf as well. So Dr. Martin Carroll is an assistant investigator with the study, and we've really enjoyed working closely with Dr. Carroll for the last year or so, getting this up and running. And so he'll be presenting, and he will introduce himself. So I don't want to steal his thunder. He will also introduce Akmal, who is part of the research team as well, and going to present today. So please note that the team has prepared their presentation specifically for a patient audience, but we do know there'll be a mixed audience here, so we're glad to have clinicians and scientists as well. We will try to get to patient questions first, but please feel free to ask the presentation at any point. You can click on the Q&A icon. You'll see a little box with a question mark at the bottom of your screen somewhere that says Q&A. So please use that to type in your questions, and note that you can actually select to ask those questions anonymously if you'd like. But regardless, I'm just going to read the question out to our presenters to answer. So we won't reveal your identity regardless. And I think that's it. Dr. Carroll said that he would love for you to interrupt and ask questions, but since we're webinar form, you can't exactly do that. So feel free to ask your questions, and I'll monitor that Q&A icon. And if there's something that makes sense for me to interrupt the speakers with, I will. Otherwise, I'll hold those questions till the end. And I think that's my spiel. So, Dr. Carroll.
Thank you, Amanda. Good afternoon, everyone, or good evening for those of you on the East Coast. Welcome. Thank you so much for joining us. We're excited to kick off this new research enterprise with we're calling the RUNX1 Patient Tissue Bank. As Amanda just started to introduce, this is our research team. In the patient tissue bank part of the org chart starts with Jimena Jordan-Bruno, who has helped to organize all this. Dr. Jordan-Bruno, or Dr. Bruno as she prefers, sees patients with inherited myeloid predisposition syndrome at the University of Pennsylvania. I'll introduce myself more in a second. Akmal and Jennifer are our research coordinators and data coordinators who will be helping with this project. This is not to suggest that this is a total org chart. The rung higher up at the org chart, actually shown in the lower left here, which is the RUNX1 research program. Katrine, Amanda, Catherine, Lydia, and their team do an amazing job basically organizing those of us who are focused on doing the technical aspects of trying to come up with better ways to both understand RUNX1 FPD, better ways to treat it, better ways to help patients. And above the RUNX1 research program in the org chart are the patients, and you're the real bosses. And yes, as Amanda suggested, what that means is please do send questions. I am here to help inform you. As part of that, I want to let you know what the tissue bank is, but feel free to ask any questions that are on your minds. I think my title really should be BNIC, the Blood Nerd in Chief. I'm an associate professor at the University of Pennsylvania. I've been at the University of Pennsylvania since 1998. I've been a practicing physician from 1988 until 2024. I closed my practice at the Philadelphia Veterans Hospital last year, and I now primarily focus on running a research laboratory focused on developing new therapies, mostly for acute myeloid leukemia. We sometimes wander into other myeloid diseases, though we do not have major projects on RUNX1 FPD. I'm involved in this because I've been running a tissue bank. The tissue bank at the University of Pennsylvania is actually painted with pretty broad strokes. It's a tissue bank of patients with hematologic malignancies. And I never quite believe it when I say this, but I've been doing that for 24 years. I started this tissue bank, and that means that I've made a lot of mistakes along the way, and I've been delighted to share my mistakes with the RUNX1 team and see if we can do it better the next time around here. Um, I think we will dwell on this theme a couple of times, which is what is tissue when we talk about a tissue bank for blood cancers, hematologic malignancies, RUNX1 FPD. For the most part, in our context, we're talking about either blood samples or bone marrow samples. And, I will give my blood nerd in chief spiel a little bit later and try to convince you all that the most interesting stuff in the world is that red stuff that courses around inside your arteries and veins, and tell you a little bit about why I think so. With a broad scope here, what you need to know is that blood and bone marrow are rich sources of cells and also rich sources of DNA. There are other things that we'll go through again in more detail later, including proteins that are in the blood. These things are the basis of the biology of RUNX1 FPD and other myeloid diseases. We have figured out over time how to purify the critical elements, although we will probably still be adapting that again, as I'll come back to in a bit. Put them in a liquid nitrogen freezer and keep them for a long time. This slide is one of these animated slides that will, walk you through what exactly happens, and I'll fill in various pieces here, or Akmal will, as we go along. Conceptually, this all starts with an individual, either undergoing phlebotomy to give a blood sample or undergoing a bone marrow aspirate if a clinician has indicated that the patient needs the bone marrow aspirate and biopsy to clarify the diagnosis or stage of disease. For the most part, this tissue bank is not designed to do bone marrow biopsy strictly for research purposes. But if someone is having it done, we do want to get the tissue through asking the clinician doing that to collect a little bit of extra tissue. That sample goes into one of these tubes that most of you have probably, seen phlebotomists use. They're called vacutainer tubes. The vacutainer literally just means that they have a vacuum inside that makes it easier to get the blood out. More important actually is they are color coded. All those different colored caps actually indicate different types of things inside the cells, inside the tubes that will help preserve different parts of the blood or bone marrow sample. So for the most part in the tubes that we're collecting, there's one of two different anticoagulants, things that will keep the blood from clotting, because clotting can glom up everything and make it not easy for us to get the cells back out. The tissue processing goes on in our lab where typically we would purify 2 aspects of every sample and occasionally purify some other aspects that again I'll enrich that discussion as we go along. The 2 aspects are what may be called bone marrow plasma. In the blood, it would be called serum the way we collect it. That is the more liquid component of blood, not the cellular component. There are actually hundreds, if not thousands, of proteins in the serum. So when people talk about things like inflammation, that is often mediated by some of the proteins floating around in the blood. So if we want to know how the cytokines, they would call it, inflammatory factor in a patient with RUNX1 FPD differ from normal, we need a serum or plasma sample. Typically, we will purify some of the cells, not all the cells. We purify the cells that freeze the best. And again, I'll go into more detail later. And those plasma or cells will then go into liquid nitrogen storage. The advantage of liquid nitrogen is it's really cold and you can keep sample for decades. The end point of this is to basically preserve the samples for future research. The reason we do it this way, the reason we set up a tissue bank is that, researchers sort of spent too much of their life reading Mark Twain, and they believe that there are lies, damn lies, and statistics. Except unlike Mark Twain, they actually think the statistics increase what's called the robustness of the research. And they want to do not one sample, not to understand one patient. They want to see what the trends are across tens or dozens or hundreds of patients. And to do that, they typically, want them to have been what we would call cryopreserved or frozen, and then take out those tens or hundreds of samples at the same time and do an analysis on them. That analysis may include cytokine profiles. It may include culturing the cells. The cells we put in the freezer, we freeze viably, so they can be taken out and cultured. It may be extracting the DNA and looking to see if there are DNA mutations that correlate with different stages of the disease. The next two slides, or next three slides, I think, clarify some issues for this particular community. This important to understand that this is separate from the NIH study that some of you may be participating in. And I'll emphasize this again later, but if there's a question in your mind about which one should be involved, if you're involved in the NIH study takes the precedence. The NIH study started first, the NIH study longitudinal, but, and that's why we come along, the participating in the NIH study is a lot of work. So typically they want you to go to Washington and visit the NIH once a year, and that's difficult. The value added of tissue banks is in the number of samples. And so we are an add-on, if you will, to Team RUNX1 that will allow participation in tissue banking of patients who are not in the NIH study, patients who, for whatever reason, can't get to the NIH to participate, who want to be able to collect a sample at their local doctor's office and send it to us and let the RUNX1 FPD folks do research with it. I'm just going to scroll through and bring these all up. Who do we want samples from? A lot of jargon gets introduced when patients and doctors and pathologists start talking about genotyping. Jargon that you may hear are variants of uncertain significant, likely pathogenic. We're for the tissue bank not so much interested in those what I would call shades of biologic gray. Anyone who's been affected by RUNX1 FPD, we are interested in collecting your blood and or bone marrow. And so knowing whether or not your mutation fits into one of these is not so critically important. Also important and different than the NIH study, we want blood and bone marrow from family members who do not have a RUNX1 FPD diagnosis. Those samples will be used for comparison to the people who are affected so we can understand, what are really not just the necessary, but all of the necessary and sufficient factors that lead to someone with a RUNX1 mutation actually developing illness. And just so you know, if the jargon and the words on the screen are confusing, as I'll repeat several times between now and the end, if or when you have questions, I'll introduce you to Akmal and we'll provide you with his email address. And if you're not sure if you can participate, you just write to Akmal and he'll help you figure it out. Oop. Oh, sorry. There are two slides with maps of America. Sorry, this is the first one. This is just to make a comment about eligibility. For right now, we are restricting it to patients within the United States. This would include Alaska, Hawaii, it would actually include Puerto Rico. This is for legal reasons, and this may only be temporary, but we have never at Penn collected samples from around the world, so I need to do a little bit of studying to make sure that I'm not breaking the laws of any other country before we start doing that. So for right now, we're restricted to the United States. Um, sorry, I'm not actually a big fan of animation, but so I tend to do it in bulks. The way this works is that this should start by you providing us with your address, your home address. If you're away on a long vacation, wherever you are, we're going to send a kit to you. And we want that kit to arrive at your house. And for you to take it to a doctor's visit at which the bone marrow procedure or the blood draw is going to take place. There are a couple of things to know about that. We would typically like at least a week or two's heads up. 2 weeks is preferred for when we can want this kit to be sent out to you. And the kit, as I said, will be sent to your address. And we'll have more on what's in the kit next. But the short answer is you're going to take the kit to your next blood draw. They will draw extra tubes of blood, and there are directions in there about how to send it back to us. The preferred method for sending back, and there'll be a FedEx envelope that's pre-addressed in the package, is for you to go to an actual FedEx facility. The reason we prefer to go to a FedEx facility is we would like to receive the sample and start processing it within 24 hours of it coming out of the individual. That is what we have found is most likely to preserve cells and proteins in the state that they existed in. And so we also do not want it to get either too hot or too cold. Frozen is bad. Temperature above 98 degrees are bad. But and FedEx is more likely to do that than if you put it in one of these FedEx drop boxes that may be sitting on a hot sidewalk. That's not so good for us. Once you drop that in the FedEx box, that will come to us at Penn, and I will tell you more what will happen in a few slides when it gets to Penn. There are several things that make this tissue bank unique. We hope it is convenient, and if it's not, we hope that you will tell us. We have done our best job, but my mother would have said good, better, best, never let it rest. So please let us know if we can make it easier. The data that is associated with the cells and plasma that we collect will be linked, as the technical term, to the information about patients in the RUNX1 Patient Data Hub. That for us is a two birds with one stone sort of thing, but it's critically important. If we measure things like cytokine, DNA changes, we really want to be able to correlate that with what's going on in individuals at the time the sample was collected. This will give us broader research access. Like I said, for right now, we will, plan on collecting plasma and cells from each collection that we get. Right now, we're not planning on collecting platelets. That's because freezing platelets is a complicated business. The way our tissue bank facility is set up, we have more flexibility than to do it at the NIH to interact in real time with researchers who might want samples. And so There's one researcher actually has already reached out to me and say, hey, I may want you to actually process those samples for platelets. I have the technology to do platelet function studies, and so we can adapt things as we go. Another critically important point that makes this unique is that the research is guided by what we will, in a jargon sense, refer to as the RGPC, uh, which is the Research Guided by Patients Committee um, uh, group, and it's just what it says it is. So I'm responsible for making sure these samples end up in the freezer. If they're going to come out of the freezer, they have to be approved by a group that includes pathologists, specialists in RUNX1 FPD, and patients who are affected by the disease. This is a little bit repetitive, but just to, bear down on this a little bit. So, you know, there are a lot of different things inside the cells that float around inside our bodies that affect the biology of those cells and can lead to the development of diseases. Those things include things that most of you have probably heard about, including DNA, RNA, and proteins. It may include things that you're less familiar with, ribosomes. Things like a polypeptide is actually just the building block of a protein. What we have learned in what are now decades of studying blood diseases is that making blood cells is a complicated business. Um, and if you screw up almost anything inside a blood cell, they can go awry. For RUNX1 FPD, we know that patients are born with one abnormality, one genetic mutation, and they typically, in some individuals, they acquire other mutations over time. In other diseases, the problem is not the DNA, but the copying of the DNA and the RNA. And sometimes it's actually the function of the protein. By freezing cells, we can gain access to any of these through purification techniques after we thaw the cells, take them out of the freezer. And so, in terms of big questions, we want to understand how RUNX1 mutations affect different types of blood cells, discover if there are early markers of disease progression. So we can tell people, hey, you've been told you should go to the doctor once a year and get a blood count. You might be getting to the point where you should go twice a year. And we should develop new therapies to intercept blood cancer. Amanda, I see there are some things in the chat. Is anything there I should be responding to?
I think we can wait till the, I'll ask this one question. Thank you very much for your presentation and project. I'd like to know what's the best method for BMPB storage aiming to analyze RNA in the future. Direct freezing is enough, question mark?
I'm going to tell you a dirty little secret of my career, which is if you do things in the least expensive way, they are most likely to be sustainable. And so it sounds like who's ever asking is a little bit of technical know-how, so I'll use a little bit of technical jargon. What we do, and again, I've been doing for over 20 years, is doing a Ficol fractionation that purifies mononuclear cells. From our point of view, red blood cells and the hemoglobin they contain make things complicated, and neutrophils and the enzymes they contain make things complicated. The mononuclear cells, from my point of view, are little packages of DNA, RNA, and proteins. And if you freeze viable intact cells, you can purify any of those after thawing. In fact, if you want, you can actually just thaw into RNA extraction buffer to get RNA out of them. But like I said, we thought about decades ago doing purifications and fractionations ahead of time. That gets complicated. I mean, we have at this point, we're close to 10,000 samples in the freezer. That would be a lot of RNA and DNA extractions that we didn't want to have to do on every single sample. So, the answer is if you freeze viable mononuclear cells, you can extract RNA, whether it's total RNA or messenger RNA. I'm going to keep going, but keep putting those things in the chat.
Oh, actually, oh, never mind. Okay, she said thank you.
Okay.
Perfect.
You know, one of the things that we get asked frequently is, it's part of our consent, so on and so forth, is, are there risks for doing this? Like I said, almost always we are hoping that the samples that we obtain will be an add-on to procedure that have been ordered by clinicians, whether that's phlebotomy or blood drawing or a bone marrow aspirate. So for almost all cases, and again, I told you we have about 10,000 samples, that's about 4,500 patients. We have not had any complications related to the procedure. So there is a theoretic risk. We are going to link your patient data, and there's a theoretic risk that the confidentiality associated with that data could be compromised. For this particular tissue bank, that is a risk associated with participating in the RUNX1 Patient Data Hub, because all we will keep at Penn is information about this sample, how many cells we got, how many vials we put them into, where we put them into the freezer. And then we will have what's called a linking code. The linking code will be linked to the patient data hub. And so only if the patient data hub is compromised will there be a risk of losing confidentiality. And so that is a risk. We're going to ask your permission to do that, but it is actually really important value added for us in terms of the value of the samples. And in point of fact, many people who talk to me about my tissue bank say what's valuable is not the cells that they can get from other people, but the linked information, which we being Akmal and his colleague in arms, Jennifer, are very careful about keeping.
And Dr. Carroll, can I add that the patient data hub is very secure and it follows all the highest security protocols, FYI. Thanks.
You can add that, Amanda, and you can call me anything you want except late for supper.
Perfect.
This is a little bit of a trick question. Can you learn how your samples are used? Sort of the real answer is yes and no. Meaning we will not give individual use answers. We're not going to tell you, Mary Jones, your sample was used to study this RNA molecule. However, all of the data that is produced using these sample will be publicized. It'll be publicized through the RUNX1 FPD website. It'll be publicized through the RUNX1 FPD social media. It'll be publicized through scientific publications. So the bulk data will be available to all of you, honestly, as soon as we can make it available, which generally means as soon as we feel confident that we know what it means and that it's reproducible. This is to repeat what I said earlier, but go down in a little bit more detail. So if you're in the NIH study, or if you are one of the lucky people who are in a RUNX1 clinical trial, it is highly unlikely that there's value added to also sending us samples. So if you're going to the NIH because you're part of the NIH study, they're going to draw the samples, they will keep them there. We are still working on the software, but hopefully within the next 6 months, our data systems will be linked. And so we'll know what samples they have, they'll know what samples we have, and that'll help the RUNX1 FPD, patient research group figure out, where to get the samples they want. This is the one that gets people confused. If you're in the NIH study and you decide you can't get to the NIH and the NIH says, well, can you send your blood? Send it to the NIH. That takes precedence, again, because they're up and running, because they're doing longitudinal study, and the value added of longitudinal studies is the number of samples they collect over time. If you're involved in a clinical trial, again, samples collected for the clinical trial take precedence over the tissue bank. Again, we get asked this a lot. Why do we need both? Because not everyone participates at the NIH. It's not feasible for everyone. And basically, more samples is better. Again, this goes back to the statistics and the robustness of the results. And RUNX1 FPD is relatively uncommon, and so we want a lot of samples. They're all going to end up in Philadelphia, as shown by that big star. But look at that. They're all coming from all over the country, we hope, and they will all contribute to research. You can tell that I learned how to write essays in high school by the model of tell them what you're going to tell them, tell it to them, and tell them again. And so this is filling in details on what we talked about before, which is how do researchers get the samples out of the freezer. So what they have to do is write a proposal that's usually a couple of pages. That is reviewed by the patient committee and the scientists thereon. They tell us to send them to researchers. That's not my call. That's not Dr. Bruno's call. That's not Akmal's call. That's coming from the RUNX1 patient committee. And, if they give us a thumbs up, then and only then will we send the samples out to be used. These samples are truly precious, truly limited, and so we really want to make sure that they're used in the best possible way. This was going to be the nerdy part, but this is already getting longer than I wanted to talk, and I want to give Akmal some time. Um, as I suggested at the beginning, I am in fact the blood nerd in chief. When you guys get blood drawn, you're like, ouch. When you see blood, you're like, uh-oh, I cut myself. When I see blood, I'm like, wow, that's cool. Look at all the stuff in there. And so the way to see that stuff is not to look at a tube of blood as shown on the upper left there. There are a whole lot of ways it can be modified. And if you're a blood nerd like me, some of them come along for the ride and some aren't. So what's shown in the picture, not all the way to the upper left, but just to the right of that and down, is what happens if you can do this in two ways. You can take a tube of blood and actually just sit it on the table overnight, or you can put it in a centrifuge and spin it for a few minutes. And it'll separate into three layers. The top layer in this particular tube would be called a serum layer. That's the yellow stuff. That's the fluid level. The bottom layer is the red blood cells. And again, for the most part, for this tissue bank, we'll be throwing those out. What I'm not sure actually, because I actually found these pictures, the people on the website who made this picture realized is that this patient has leukemia. So you can actually see a thick white layer between the yellow and the red. There is always a white layer. Those are the white blood cells, named because they're white. When you separate them like this, it's usually about 10 or 20% as thick as the layer seen here, and it's this thick in this patient. In point of fact, spinning samples like this, spinning samples from patients with leukemia, was done 150 years ago, which led to the naming of the disease leukemia, which is Latin for white blood. So inside those tubes, there are red blood cells, white blood cells, DNA, RNA, proteins, platelets, serum, many, many, many proteins contained in the serum. White blood cells come in, depending on who you ask, somewhere between 8 and 18 different flavors. And when you start talking about RUNX1 FPD and inflammation, any one of those. Again, given the way that we cryopreserve cells, there's one cell called neutrophils that we can't take out of the freezer. All the rest, we could take them out of the freezer, or we could put them on an instrument called a flow cytometer, and we could purify all those white blood cells and theoretically start to test how they function, comparing function from RUNX1 FPD patient to patients who do not have the disease. And that's nowhere near as cool and important as that bone marrow stuff. You know, each and every one of you, whether you know it or not, has made on the order of 500 billion, that's 5 times 10 to the 11th blood cells in the last day. The factory that makes those blood cells is called the bone marrow. The bone marrow is the spongy part inside the white bone. If you get a bone from the butcher, if you do a bone marrow aspirate, it comes out in the tubes that you can see in the picture here, which tends to clump up much more than regular blood. Those clumps include little bony spicules, they'll call, little fat pads that come out of the bone marrow. And importantly, this, in contrast to the peripheral blood, is rich in the hematopoietic stem and progenitor cells, which are the magic cells, which probably explain a lot of the biology of RUNX1 FPD, which are used in stem cell transplants or bone marrow transplants, and have many, many, many properties that are totally cool to think about. So those are some of the things that we're getting when we do a tissue bank of blood and or bone marrow. This is the procedure I mentioned before. This is a cleaner way to do the separation that I talked about. What you're looking at the top are two different, they're called sediment gradients. The one on the right is the one we use. That's a phycol gradient. And again, the red blood cells are all the way at the bottom. Right above that is actually the phycol itself. Above that is the white blood cells. And above that is the serum. What we will actually do is stick a long skinny needle into this tube, take out the white blood cell, and those are the ones that will go in the freezer. The picture at the bottom says -80. That's actually just overnight. Liquid nitrogen storage is -140 or colder, and so it's -80 overnight and then even colder for the next 20 or 30 or 40 years. Okay, let's try again, Amanda. Questions for me, or should I just go ahead and hand it over to Akmal?
One quick question is, do you want samples from patients with MDS or other malignancies?
That's a more complicated question than it sounds like. So if they come from a family with familial RUNX1 FPD, yes, we do. If they do not, then we can't, is honestly the legal answer. So the consent for the RUNX1 FPD tissue bank is a consent for exactly that, to collect sample from patients and family members of patients who have RUNX1 FPD. If you have MDS or other types of blood cancers, there is a whole nother, obviously I run a tissue bank, I know a lot about it, but we're only allowed legally to collect samples from patients seen at the University of Pennsylvania. So if you have a RUNX1 familial mutation or someone in your family does, then yes, MDS, other diseases. A full answer or discussion about MDS gets quite complicated because it's honestly a complicated group of diseases, but let's leave it there for now.
Okay. And actually that reminds me, we did get an early question that was related. So if they qualify, if they have RUNX1 FPD and have had malignancy and have a stem cell transplant, we also would like samples from them as well, correct?
Correct, we would, although, you know, in that case, the usage of them will probably end up staying in the freezer a little bit longer because not that many individuals have had them, you know, and so we do this now at Penn for patients who undergo transplant for other indications. Typically, those cells, what we're most interested in, are lymphocytes, which help us to understand for which patients the transplants work and for which they may not work as well. And so, yes, we do want the samples. They will probably be used for a slightly different set of research projects.
Okay, perfect. I think we are ready to move on. Thanks, Dr. Carroll.
You ready, Akmal?
I am. Greetings to everyone on the call and everyone else who might be tuning in later watching this recording. My name is Akmal. It's my pleasure to be here today as the very first research coordinator for the RUNX1 Foundation. And I look forward to support you and the many future volunteers, contributors to the RUNX1 Tissue Bank and the research community with your precious samples. I just want to quickly walk you through my role and how I and Jennifer, my colleague in arms, could be in support to you in every step of your involvement with this foundation. From navigating the registration web, as you can see on the left side, to scheduling your appointments for blood draws or bone marrows, to shipping those samples back to our lab. On the right side of the slide, you'll see a QR code, and if you have your phones handy, you can hold your camera and that will provide a link which should take tricks. You can also, if you don't have time, watch this video later and then do that. And throughout these slides, I understand that all the steps may feel like a lot. Martin went over a lot of steps. And I just want you to know that Jennifer and I, we are a phone call or an email away if you have any questions with any of these steps. So to set up your page, you will see on the login page, click Not Registered. And if you already have an account through the Patient Data Hub, you should already be able to use those login and passwords to also log in here. Okay, let's move on to the next slide. So once you set up your account, you will come across a page to complete some consent forms, where on your dashboard you will see those forms. And once you complete the consent form, it'll take you to the your actual dashboard where you'll see tissue bank selection coordination form. And there, we want you to provide your appointments for your bone marrow procedure or blood draws, as well as your address. That gives us the information to be able to coordinate with you and send the collection kit to your address. And as Martin mentioned before, it would be great if you filled this form at least 2 weeks before, so we have the time to prepare and send the kit to you. It's also important for you to schedule your appointments earlier in the week, preferably from Monday to Wednesday, because we don't want these shipments to get held up in shipping facilities. So as Martin also mentioned, your cells, once they come out of your body, they can't stay alive forever. And we want to be in our lab. It would also be great if you are able to schedule your appointment earlier in the day, preferably in the mornings or noons, so that you have time to repackage your blood and then drop them off in the FedEx office. So once we get your address, the process of coordination begins and send you a kit upon 2 pieces of paper. One is an information sheet, which just goes over your involvement with the RUNX1, all the basics, any questions you have. And the second sheet, which is a sample shipping instructions, which guides you step by step on how to open this box and then repackage it when you're ready to ship it back to us. And we ask that you bring this complete kit with you to your appointment and ask your phlebotomist, your physician, to fill the tubes. During your appointment, we also ask that you bring a gel pack, which you can insert along with your tubes and then ship them back to us. One thing I forgot to mention, the gel pack you will find in this kit please freeze them for at least 24 hours before your appointment so that they're completely frozen and ready to ship the samples back to us. As Martin said, there is an optimal temperature we want these samples to be in during transit. Bring your kit with you to your appointment along with the frozen gel pack. Please read through both the information sheet and the sample shipping instruction and follow the instructions carefully. Again, if you have questions about any of those steps, feel free to email or call me. So when you get your blood drawn, either the phlebotomist or your provider will make sure to label every tube. That label includes your name and your date of birth. And if you are concerned about that information being there associated with the RUNX1 tissue bank in transit, worst case scenario, if the kit gets lost or stolen, then you can cover that information or cross it out. Because every tube will have a randomized identification number, which we, the tissue bank, can connect it back to your identity. If you can, you can drop off the kit on the same day after your appointment to a FedEx office, preferably on the same day if you have to go home afterwards. And last step is once you have packaged and sent the kits back to us, we ask that after you receive your results from your lab team from the tests done on your procedures, your blood sample and bone marrow, we want you to log back into your research portal, find the tissue bank blood count information form, and enter your red blood cell, white blood cell, and platelet counts, etc. You will also find a tab where you can submit documents, any electronic reports you've received, and we can upload that information on your behalf. Again, if there's one thing I want you to take away from this slide is that if you have any confusion or questions, I am a phone call or an email away. Again, it's nice to meet you all. Akmal, the research coordinator, and Jennifer, we're here to support you.
Thank you, Akmal.
Yep.
Amanda, questions for Akmal?
I'm back. Thanks. Yes. We have a few here. We have one question is, this is a good question and I've been wondering it. Can we have our clinic lab ship these back themselves because there's no FedEx office in rural areas? The clinic labs do have FedEx pickup.
Great question.
Thank you, Akmal.
Yep.
Amanda, questions for Akmal?
I'm back. Thanks. Yes. We have a few here. We have one question is, this is a good question and I've been wondering it. Can we have our clinic lab ship these back themselves because there's no FedEx office in rural areas? The clinic labs do have FedEx pickup.
Great question. So there are lots of nuances which we will try to figure out with you. So if you let us know beforehand, we can contact your providers and figure out how they can ship these back to us. The collection kit will have a prepaid return label, which should make it easy for either you or your providers to ship these back to us. And again, you should email or call me ahead of time so I can coordinate both with you and your providers to work this out. The goal is to ship these samples the same day. We don't want them to be left overnight because the viability of these cells drop precipitously after a certain time, and we don't want that.
And just to address a couple of practical issues there, so as Akmal implied, that should work absolutely fine. what's going to happen is that the phlebotomist, the nurse, the doctor is going to say, wait, what are we doing here and what's it going to cost me? And the answer absolutely should be it will cost them zero, you know. And so the basically you'll get a prepaid envelope to ship in that will be charged to our account. Basically we just need some way to get it into the hands of a FedEx person. And I don't think, like I said, they may ask, hey, you sure you're not supposed to have your name on this or on these labels? We never send blood without labels. From a legal point of view, this is a research study, and so samples should be de-identified. This is not clinical work, but I think those are the two issues. And like I said, those are the things that the people in the office are going to ask. From our point of view, if you get into the hands of FedEx, it's all good.
Question. Okay. Let me look at my list. Several people sent in questions ahead of time. So this is so if they have annual bone marrows or multiple times a year which they have blood drawn, do you just want one sample, or is this something that they should continuously submit samples through into the tissue bank?
I hate to sound greedy, but the answer is the more the better. And so, as I said, for the most part, this is the intent built very much into the NIH study, which is multiple samples. That study is actually designed to collect samples potentially over decades. I know that Dr. Liu, who runs that study, already has samples over several years from, several dozen patients, and wants to keep collecting. That's the whole point, is to define the natural history of the disease. We will certainly take them. If you're not going to the NIH, we will certainly take them. And yeah, like I said, they will be annotated. Did we decide, Akmal, will they have to fill out a new form to get a new envelope when they go into the data hub, or can they just email us and ask for a second shipping package?
If they have a new appointment, there will be another form they're going to have to fill out.
So a new tab basically on the data hub matrix website.
Correct. Yeah, that way we get an update on our end, and we know if any addresses have changed, and we can ship a new collection kit.
I'll chime in to say specifically, since this is also new and we had different ways of thinking about this, that I think the way it's going to work in the system is they'll need to go to the completed form section and go back to that same tissue bank coordination form and click retake. There's 3 dots to the right, and then click retake, and that'll put a new form in there for them to complete. And but if you have any questions, again, reach out and we can walk you through that. Great. And then it's so interesting. Are you able to accept other types of tissue? Like we were asked about cord blood that has been stored. We've been asked about other types of biopsies on solid tissue that might be happening. Is that something that could be submitted?
For the most part, the answer there is no. There are reasons for that. Some of which are legal, some of which are practical. So cord blood is certainly of research interest. If, cord blood has been stored for any reason, we would probably prefer that be used for other research projects within the RUNX1 research program. And I recommend you can either send me an email, send Amanda or Katrine at the foundation an email, and we can help you with that. Other tissues are more challenging, honestly, because they would have to be processed in quite different ways. But again, what I would say in individual cases, reach out. And, I can speak to Dr. Liu, I can speak to Katrine, and see in individual cases, if we think there are researchers who would find that valuable, the match here, if you will, is basically between processing and use. And so, like I said, because we've done this for a long time, we've figured out the simplest way to process to create the material that can be used by the most researchers. For tissues from other organs, the way we do things may not be the best way. And so typically we'd want a conversation with, about how the tissue is going to be used, and that would affect the answer to the question. But that's not the routine use of the tissue bank protocol here.
Okay, I think you've already answered this final question I have on my list, which is, can you tell me exactly which research or institution receives my samples and anything that's found out, from my specific sample? Is that possible?
There are two different questions here. So, and I'm sorry, not sure I completely emphasize this. So the samples are getting sent to the University of Pennsylvania. The samples can be sent out to anyone who asks permission from the RUNX1 FPD. We will not give individual specific data. The foundation will make available, probably on a semi-annual or annual basis, a list of, who used the tissue bank, who will include the name of a researcher in the institution. And again, at this point, we're probably restricting use to researchers within the United States until we figure out some of the legal possibilities. And then through separate social media publications, which are also going to be linked to the researcher who did the work, you'll be able to get information about, overall what experiments were done, what results were found.
Yes, and we do offer a lot of webinars and different, research webinars featuring scientists who are studying this disease, and we try to make those available to all of our community, to patients to come in and listen, as well as at our annual conferences. So that information will be shared. So great. I think we covered all the questions that were submitted live and ahead of time. Thank you both so much. Martin, I can't help but think, I hope you still teach, because I learned a ton about blood today, and it was really fun to listen, and I hope you get to do that a lot. I enjoyed listening anyway. So thank you. And thank you, Akmal, for your presentation about all the logistics. It was really clear, and I think really appreciate that you're available, like you offered your cell phone number even to the community. So look forward to continuing to work together.
Happy to be here.
Guys.
Thank you.
Thank you, Amanda. Thank you to all for coming, and let's lick this disease and make us all live to be 152.
Sounds good. Let's do it. Okay. Take care. Have a nice evening. Thanks everyone for coming.